Welcome to Grateful Test Prep. Call or text us if you're interested in one-on-one online tutoring, and feel free to smash the thanks button if you'd like to show your gratitude for how much these videos are helping you to prepare for your test. Right now, we're in March 2022, Section 4. Let's go ahead and get started. So here we have a question that's talking about humans beginning their REM sleep 90 minutes after falling asleep, and it's asking us how many seconds that is. So we can start with 90 minutes. Any number is really itself over 1. And we can throw in a conversion factor that's equal to the number 1. 1 minute is the same as 60 seconds. Now we can do that because 1 minute and 60 seconds are the same thing. They're equal to each other. So putting them in a fraction, one on top of the other, is just like the number 1. Or for a good comparison, it would be like the number 5 over 5. But when you do that, the minutes cancel with minutes. Minutes cancel with minutes. That gives us 90 times 60. 9 times 6 is 54. So this is 5,400 seconds. And that's answer choice B for number 1. Number 2 is giving us a function and asking us what's g of negative 3. That basically means replace x with negative 3. So g of negative 3 is 4 times negative 3 minus 2, negative 12 minus 2, and that's negative 14. And that is D for question 2. Going to number 3 now, we're seeing that BC is 2 times the length of AB. So if AB is x, that means that BC could be called 2x. And BC is 20, so we can say 2x is 20. And which equation represents this situation? That matches answer choice D for number 3. Going to number 4, we have people, 2 people, Jeremy and Eric, and the rate at which they sweep the floor, the rate of how fast they can sweep the floor. So Jeremy does 12 square yards per minute, which it says right here, and Eric does 16 square yards per minute. So if each one sweeps the floor for 5 minutes, how much greater does Eric sweep than Jeremy? Okay, so we have 5 minutes. Let's do Jeremy. Jeremy's doing 5 minutes. That's the same as 5 minutes over 1. Anything's itself over 1. And now we can multiply by 12 square yards for every 1 minute. As we just explained a moment ago, if you have 12 square yards every minute, then that kind of means that 12 square yards and 1 minute have the same value. And putting 2 things that have the same value in a fraction over each other is the number 1. So we're not changing the value of the 5 minutes, we're just changing the way it looks. Minutes cancels with minutes. 5 times 12 is 60 square yards. So in 5 minutes, Jeremy is going to do 60 square yards. Now we can go over to Eric. And in 5 minutes, Eric is going to do 16 square yards per minute. And 5 times 16 is 80. So we have 80, and the unit is, once again, square yards. Make that a little more beautiful there. Square yards. And that's because minutes cancels with minutes. So now, how much greater? That's code for subtraction. So we're taking these 2 numbers, this, and we're subtracting them. 80 minus 60 is 20, and that's A for number 4. Number 5 is asking us for an equivalent expression. So if we're distributing the x4th into all these 3 terms, Well, that brings up the idea that if I have a to the b times a to the c, in that situation you would add, and it would be a to the b plus c. So when we multiply x to the fourth times 3x squared, there's going to be a 3 there, but we're adding the 4 and the 2, so that would be x to the sixth. Multiplying x to the fourth times 9x, so there's a 9, and here this is x to the first, so if we're adding 4 and 1, we'll get x to the fifth. And x to the fourth times negative 8, that's just negative 8x to the fourth. So 3x to the sixth, 9x to the fifth, minus 8x to the fourth, and that's B for number 5. Number 6. Number 6 is dropping a nice code word, y-intercept. And we're supposed to know that for the x-intercept, that means that y is 0. For the y-intercept, that means that x is 0. And so, because they said y-intercept, we're going to make x 0. So that would be like saying f of 0, 2 times 0 minus 4. That's 0 minus 4, so it's negative 4. So we have x is 0 and y is negative 4. And that's answer choice D for number 6. Now we're going over to number 7. It's got a table. Okay. A public school will be selected randomly. What's the probability of selecting a school in San Diego County? Now, what we're picking from is only the middle schools. So this is conditional probability. When they say we're only picking a middle school, they're saying only look at the purple part of the graph and ignore everything else. Now these totals, we were kind of ignoring those anyway because those same numbers are already included in there. They're just the totals of the numbers that we already see. But if we're only looking at this purple area, that purple area, we can think of it as a part over a whole, because probability in general is a part over the whole. This is conditional probability, where we're looking at the part over the whole, but only for a certain part of the graph of the table. And so the whole is 587, 422 plus 165, and San Diego County is the 165 that goes over that. And so we can just throw that in our calculator, 165 over 587, and that gives us 0.28109, so 0.28, and that's C for number 7. Now on to number 8. So we have a scale model. 1 mile in the model is actually 400 million miles. So this is our model, and these are our actual distances. And if the model is X miles away from the model of the Earth, so the actual distance away is X, and actually they're telling us it's the model distance that's X. And what's the actual distance? So this is a little difficult because they didn't give us a variable for this, but let's call it y. And y is the actual distance. So now, just stopping for a second, we have the ratio they gave us, and we have the question. And then we've got the model distance and the actual distance. So this is how you can keep from being confused on one of these questions that almost seems like it was intended to confuse, to be honest. But from here we can cross multiply, solve for y. Y represents the thing we're looking for. So y times the 1 mile, so we're kind of cross multiplying like this. is going to be equal to x times the 400 million. So y times 1, which I won't write, equals x times the 400 million. And that is, believe it or not, answer choice A for number 8. Number 9 is giving us a list of numbers. A seventh child with a height of 60 is going to be added. How will the mean and the median change? Okay, so if we had a 60 right here, the way in which the mean would change is very easy, because if I have a bunch of numbers and a number comes in that's higher, it's going to raise the average. If a number were lower, it would lower the average. So we know that the mean is going to increase. The median maybe is a little more complicated. What was the median originally? If we look only at this area, we've got 1, 2, 3, 4, 5, 6 numbers. We have an even number of numbers. When you have an even number of numbers, what you need to do to get the median is you take the actual arithmetic mean of the two middle numbers. So those numbers are 54. So the original mean, the original median is 54. Now, when we think about the median of our new set of numbers, now we have 7 numbers in our set. And to find the median, you can realize that there's 3 on this side and 3 on this side. Therefore, the middle number is this number right here, which coincidentally is also 54. So the new median is also 54. And so as you can see, the median did not change. The mean did change. And so, which answer says that? The mean will increase, the median will remain the same, and that's C for number 9. And we're going over to number 10, even though my screen jumped. Thank you, Microsoft, for that. Okay, so there's a little 5.0 that's cut off from the screen here, but we're just doing the best we can to fit everything onto one screen. And the line of best fit underestimates one student's reported average time. For how many hours did this student report? Okay, so they're saying, where is it that the line underestimated the actual student? On so many graph-based questions on the SAT, the trick is to reverse the inequality. It is a little difficult mentally to think about a situation where the line is under the actual value, but for some reason, it's actually easier to think of a situation where the actual value is above the line. In other words, we're looking just for a point, a dot that's above the line, and that's happening by more than 2 hours. So where is there a dot that's more than 2 above the line? So for instance, right here, this is a distance of 1, 1. This is a distance of a tiny bit more than 1, and so on and so forth. This is 1 right here, so that distance is a little more than 1. This is also 1, so this distance would be like 1.5. But the one that stands out is this point right here, because it's a distance of 1, 2.5. So that one, the actual value is 2.5, roughly, greater than the line. So that's the point we're talking about, this red one right here. For how many hours did this student report reading? This student reported being offline for 1.5. Be really careful with that, because I was fully ready to say it was 5, right? Because look, it's 5, right? Isn't it? But the SAT in its cleverness is asking us about the offline, which is the x-axis. So the number there is going to be 1.5 for number 10. Nice little devious, tricky question for us there. let's go ahead and look now at question 11. Just clear this out a little because we know we're going to need it. And let's zoom in a tiny bit. Okay, question 11. According to the line of best fit, student spends an average of 1.25 hours reading offline. What's the estimate of the time that would be expected to spend using the internet on Saturdays? Okay, so what we're kind of talking about here is the dynamic of actual versus predicted. You know, you just want to be really careful. Which are they asking you about? The actual values are the points, the predicted values, the line. And the student, they're telling us according to the line. That's super important. So we're not looking at the points, we're looking at the line. So where does the line say that the student is offline for 1.2 hours? So this is the axis for offline. And 1.25 hours is going to be halfway between 1 and 1.5. So we're talking about this point right here. And what is the estimate of the time using the internet? So in other words, what's the y value? To me, it's 2.75, which is going to be C, between 2.5 and 3 for number 11. Now we're going to 12. Line K is defined this way. Line J is parallel to line K. What's the slope of line J? So the line they gave us, K, looks like this, negative x plus 5. If we do that as a y equals mx plus b, that means that the m is the negative sign, negative 1. And the b, by the way, would have been 5. So what is the slope of a line that's parallel to that one? Well, parallel means it has the same slope. So our slope would be negative 1, and that's A for number 12. And now we're looking at 13 here. Okay, so combined, the students answered 17 questions. A total of 9 questions were answered in group V. This describes the situation. Okay, what's the interpretation of the 4R? Okay, so this is our good one. This should be question 38, just looking at it, right? So we have the students in both groups are answering a total of 17 questions, and this equation here adds up to 17. So when we say something equals 17, we're writing an equation about the total number of questions. And so that leads me to believe that out of the 4R and the 9, one of them is the number of questions answered by one group of students, and the other one is the number of questions answered by the other group of students. Now we're seeing that it says a total of 9 questions were answered by the students in group V. So we just saw that this is the number by group V. So what's the 4R? It's the number of questions that were answered by group R. That's what they're asking you. Which of the following is the best interpretation of the 4R? In my words, it's the number of questions answered by group R. And that is matching answer choice C for number 13. Now we're going over to 14. How many solutions does this thing have? Well, there's a couple ways to approach this, but let's just start by distributing and simplifying. 5x plus 5 equals 5x plus 5. Okay, well, let's just say that we did minus 5x from both sides, and we make the x's disappear. That would leave us with 5 equals 5. And what's the rule here? When the variables drop away, if you're left with a true statement, then that means it's all real numbers. And if you're left with a false statement, it's no solution. So here, what were we left with? 5 equals 5. As weird as that is, it is true. 5 is equal to 5. So that is all real numbers. And that's D, infinitely many solutions for number 14. Now we're going to 15. Table shows the results of a survey on the average amount of money consumers would be willing to spend on a product and their corresponding age A in years. Which equation could represent this linear relationship? Okay, so let's just go ahead. Well, let's think for a second about what the variables are. D is the money in dollars. A is the age in years. You want to be careful with that because a lot of times, especially for the X value, which here is the A, you'll often hear, X is the number of the age, or let's say it's the number of years after 20 years old, in which case this would have been 5, this would have been 6. That's kind of what you're looking for on an SAT, but here it's a little more straight. And anything linear, these are all y equals mx plus b, so this is a linear situation. Anything linear, you're going to want the slope. The slope is the change in y over change in x. So how much is y changing? Well, from here to here, actually, let me draw the arrow in the other direction. From here to here, it's going down by 6. And from here to here, it's going up by 3. So negative 6 over 3 is negative 2. Now, does this thing have a negative slope? Absolutely it does, because as the x's are increasing, the y's are decreasing. So yeah, it has a negative slope. It's on its way down. Slope is negative 2, and that's this right here. It's the only one that's got a slope of negative 2. And so the answer for 15 is A. Now we're going over to number 16. What is the value of x plus 1? Just a matter of playing with this a little bit. So let's start by distributing the left-hand side, 4x plus 4, and on the right-hand side, 6 and 2x plus 2. Combine some like terms, 4x plus 4 equals 8 plus 2x. And we're looking for x plus 1, so we can just kind of start maneuvering this to look like that. So if I take away 2x from both sides, I've got 2x plus 4 equals 8. And if we take away 2 right here, maybe a little curious why I'm doing that, but I think you'll see. We have 2x plus 2 equals 6. But what we wanted was x plus 1. So what's the relationship between this and that? It's just a matter of dividing by 2. So if I divide both sides by 2, I'll get x plus 1 equals 3. And that is B for number 16. We call that corralling. We're not interested in what x is. We're interested in what x plus 1 is. So finding x, believe it or not, would actually be a waste of time here. And also would possibly lead you to pick a wrong answer, because let's just say, x here is equal to 2. So if 2 is one of the answers, in a moment of spacing out, we might pick that wrong answer. Now we're going to question 17, which is asking us about graphing an exponential equation. So let's just go ahead and start with reviewing the basic exponential equation. It's in the format of a times b to the x. A is the starting amount. B is the way it changes. And x is the number of times that all happens. And we also know that the SAT frequently quizzes you on the idea of whether that x gets transferred into something like this or like this. If you see something like this, that would be like saying that our change is happening every 5, let's say, years. And if we did something like this, that would be like saying that our change is happening something like 5 times per every, let's say, year or whatever we're dealing with. So applying that to this question, we know that it's starting at 10,000, 10 or 10,000, whatever, and it's going to be doubling, but it's not going to double every year. That would be just a regular x. It's going to, or every hour, that would just be a regular x. Instead, it's going to happen every 12 hours. So that's this idea right here. It's every 12. And so let's just put a little yellow box around this because that's the general rule for this question type. And now that we have that, we can kind of go ahead and start plugging in some of the points we were given. For instance, this red point right here is saying that when x is 0, y is 10. So let's try that. Is y 10 when x is 0? And that does seem to match up because anything to the 0 power is 1 and 10 equals 10. So far, so good. Let's try another point. Maybe like this blue point right here is saying that when x is 24, y is 50. So let's try that on. So when x is 24, y is 50. So 50 would equal 10. This is all for answer choice A that we're trying right now. 50 is equal to 10 times 2 to the 24 over 12. And so that's 10 times 2 to the second. And 50 is equal to 40, which shows me that it wasn't actually a 50 there. It was actually 40 because it's one line down from 50. So I was wrong when I said it was a 50 there. It's actually a 40. And that actually does hold true. 40 is equal to 40. And let's try one last point. Maybe this one right here that seems to say that when x is 48, y would be 160. So 160 equals 10 times 2 to the 48 over 12. So we're just plugging in x is 48 when y is 160. So we have 160 is equal to 10 times 2 to the fourth. 2 to the fourth is 16. So 160 equals 10 times 16. And that is true. 160 does equal 10 times 16. So we tried a bunch of points for answer choice A, and they all worked, which is why the answer for 17 is A. Moving right along now. Moving to question 18. Question 18 is asking us about box and whisker plots, also known as box plots. And let's just do a quick little review of how to make a box plot. I'm going to create some data just to kind of demonstrate how box plots work. So let's say we had 7, 9, 11, 25, 36, 37, 38. Those are my 7 numbers there. So the first thing you're going to want to do is find the median. So that is our median. What the median does when you're doing a box plot is it splits the data into 2 groups on either side. Then you want to find sort of the median of each of those groups. I might call them the submedian. It's not really what they're called. We'll just kind of call it that so we have something. And those are our submedians. Now, when you're creating the box plot, you have the smallest value, the largest value. We have each of the submedians creating our box. And then we have, okay, so that's 9 and that's 37. And last but not least, the whisker is the median of everything. And that's how you do it. So you have sort of 5 critical numbers you need when you're creating a box plot. The median of everything, the beginning of the numbers, the end of the numbers, and those submedians. Now, the SAT actually does use some of the fancy terminology sometimes. This first submedian is called quartile 1, the second one is quartile 2, and the third one is called quartile 3. And the subject that actually did come up on an SAT is what's the interquartile range? The interquartile range is the distance between those 2 submedians, also can be called the length of this box. So the interquartile range with my numbers here is 37 minus 9, which is 28. So all of that is fair game on your next SAT. So if we want to deal with the range of each of these, the range is simply the distance between the lowest and highest numbers of each of these data sets. So we're looking for the one that is going to have a range of around 6, and the one that has that is data set D, because it's going from 3 to 9, which indeed is a distance of 6, and so the answer to 18 is D. Going over to number 19 now. So 19 says we need to know about when a tree is selected at random from the entire forest, we need the probability of selecting a tree that is not hickory or oak. So what is T representing? It's the total number of trees. H is the number of hickory trees. And K is the number of oak trees. So if we're getting a probability in general is the part over the whole. And the whole group is the total T. The trees that are neither hickory nor oak, so not those two guys, that would actually surprisingly be the total number, and we can subtract away the hickory and oak because those are the ones we don't want. So we're going to subtract H and K from the total, and that'll give us the ones that are neither hickory nor oak. And so we can distribute that minus. That minus is really like a -1, so we can distribute that. So that'll give us T minus 1H minus 1K all over T. T minus H minus K all over T, and that's answer choice B for number 19. Going over to 20. 20 is quizzing us on the vertex formula of a parabola. So you definitely want to know this formula by heart, be able to use it and understand it. In this formula, H and K is the vertex. And A is going to give you your opening direction. And it's also going to contribute to your vertical stretch. So the interesting thing about this, for instance, I'm just going to create some numbers just to show you. Let's say we had 5x minus 7 squared plus 8. The vertex for this parabola that I just created is actually +7, +8. And that's because the formula has a minus sign in it already, which means that if I want to know what numbers went into it, I have to actually take the opposite of whatever number you see in this spot, because the minus sign was there before we put the 7 and the 8 into the formula. So that's just the kind of the confusing thing about this. So in the equation that they gave us, we know because of this minus sign that it opens downward, and we know that the vertex, like I said, we need the opposite of this number, the opposite sign, and we need the same sign as this number. So the vertex would be -h and +k. So if you have a negative x value and a positive y value, that puts you in quadrant 2. Every number in this quadrant has a negative x and a positive y. That's how you get to quadrant 2. So what do we know about this parabola? It starts in quadrant 2 and it opens downward from there. We don't really know if it stretches into quadrant 4 or not. It doesn't really matter. We just need to know where the vertex is. It's in quadrant 2, and the answer for 20 is B. Now we're going to number 21 here. Okay, so 21 has a lot of sort of conceptual stuff to explain before we get into it. Let's just say that I had a number and I want to lower it by, let's say, 10%. That would mean that we would start at 100 and we would just simply add 10 to that. By the way, if I wanted to lower it by 10%, it would become 90. And then we can put both of those numbers in decimal form. And so what we're saying here is if you want to add 10%, to a number, that's the same as multiplying it by 1.10. If you want to take away 10%, that's the same as multiplying by 0.9. And that's the idea of applying a percent change. The problem is, if I'm lowering something by a letter percent, there's no place to put a decimal on a letter. So you can't use decimals. You need fractions. So let's just remind ourselves that the word percent, sort of the Latin root of that word, is for 100. So for instance, 100% is the same as saying 100 over 100. So if we did kind of the same thing that we're doing in yellow, but we're using fractions instead, 100% looks like this. And now, if I'm going to take away r percent, I'm just going to do 100 minus r over 100. Let's actually put the plus on that side, just to keep with the yellow diagram above. And if I wanted to take it away, so if I want to add r percent, it's 100 plus r over 100. And just make this neater. And if we want to take away r percent, that's like saying 100 minus r over 100. So in pink, we're adding r percent to something. That would be the same as multiplying it by 100 plus r over 100. And taking away r percent would be the same as multiplying by something by 100 minus r over 100. So, long story short, we can take that 500 and we can, if we're taking away r percent, we can multiply it by 100 minus r over 100, which matches answer choice A for number 21. Question 22. We have the area of a right triangle. Now, by the way, this is mimicking the equation 1/2 times base times height. We'll get into that in 1 second. Now, this is for a right triangle. And when you're talking about the area of a right triangle, there's something special going on there, because a right triangle has a hypotenuse and 2 legs. Let's call them leg 1 and leg 2. And if I were getting the area of this, I would say, well, the area is 1/2 times the base, which is in red, times the height, which is in purple. That's for any triangle. But what makes a right triangle special is that if I turn this thing sideways, if I rotated it, not to scale, but if I rotated it, I could have leg 1 here now, and leg 2 here now. And now, leg 2 is the base, and leg 1 is the height. So what am I demonstrating here? I'm demonstrating that for a right triangle, the base and the height are interchangeable. They're simply the 2 legs. It doesn't really matter which is which. But they gave us 1/2 times b times 2b. Well, which of these is bigger, b or 2b? And of course, 2b is bigger because it's double of 1b. So they're saying out of the 2 legs of the triangle, which one is shorter? We know that both of these are the legs because of our explanation about the area of a right triangle. But which one is shorter? Obviously, b is shorter than 2b. And ironically, the answer for 22 is b. Now we're going to number 23. Boy, does 23 look like it's talking about something so much more complicated. But to start it off, we know that it's about the volume of a cylinder. And the formula for that is pi r squared h, and that's given to you on the formula sheet for the SAT. Now, if we just think about a cylinder has a circle at either end, and then it's stretched apart like a soda can. And we're seeing that the diameter, this green distance here, is 0.1 meters. And they called it the length. The other dimension of it is the length, and that's the 1. So this SAT is being a little confusing in the sense of referring to the height of the cylinder as a length. And that's kind of the little confusingness of the question, but it's still the same height that we know of as a height in the formula. So if we plug that in to the volume of a cylinder formula, the radius is going to be half of 0.1. So if you go on your calculator, 0.1 times 1/2, you would get 0.05, and that's squared, times the height, which we said was 1. And throwing that in the calculator, 3.14 times 0.05 squared times 1, which I'm not going to type in because if you multiply something by 1, nothing happens. But that'll give you 0.00785. So that is the volume of one of what they're calling sections, ice core sections here. But the question is asking us about 94 of those. So if you take that number and multiply it by 94, you get 0.7379. If you round it off, it's just 0.7. And that's why the answer to 23 is D. Going to 24 now. We're being asked to prove, or what we would need in order to prove, that these two triangles are similar. First of all, what does it mean to be similar? Similar shapes have the same shape, but are different sizes. And by the way, the side lengths are going to always be proportional. Same shape and different size. What does it mean to be the same shape? That means that all the angles are equal. So, looking at these two triangles, we know right off the bat that this angle is equal to this angle. So that's non-negotiable. And if the lines were parallel, if DE is parallel to HG, that brings some other things into play, because for parallel lines, what comes up really often with parallel lines and transversals on the SAT is the idea of C's and Z's. So if I have two parallel lines and my angles form a C shape, we're supposed to know that these two angles here add to 180. And if our two angles form a Z shape, we're supposed to know that the two angles at the elbows of that are equal to one another. So if these lines are in fact parallel, then I can see a Z shape right there, and I can see that this angle has to be the same as this angle, the two purple angles. And maybe a backward Z would tell us that this blue angle is equal to this blue angle. So if the lines are parallel, we just found out that all three pairs of angles match up. And that would indeed prove that they have the same shape. The angles are equal. The angles are congruent. And so if DE is parallel to HG, then yes, we know that they're similar. But looking at answer choice, looking at option 1 there, we're going to leave the two vertical angles at F congruent, because those are congruent no matter what. But if DE is a third of HG, does that tell us that they're similar? No, because just because one pair is in a proportion of 3 to 1 or 1 to 3, that doesn't mean that the other pair of sides, the other two pairs of sides, are in the same proportion. We just don't know that yet. So this is not enough to say that they're similar, but the other one is. And so for 24, we're going to say B, that option 2 is sufficient, but 1 is not. Now we're going over to question 25. And we're looking for a data point where the actual y value is 2 more than the predicted. So we're talking about actual versus predicted. The actual values are the points, and the predicted value is the line. So we need one of them to be 2 above the other. That looks a lot like this. The only problem is that one box on this graph is not equal to 1. The distance, let's say from here to here, is the distance from 18 to 20. And the distance from here to here is the distance from 16 to 18. So each space vertically here has a value of 2. So if we're going 2 spaces, that's actually a distance of 4. So this is 4 right here. On the other hand, the difference right here is a distance of 1. Because at x equals 5, the line is predicting that the value will be 28, but the actual value was 30 there. So going from 28 to 30 is, of course, a distance of 2. So that's our point right there. It was the point where x equaled 5 when y equals 30, and the answer for 25 is D. Going over to 26 now. A plant's height is 1.25 times its height from the last week. What's the percent increase? Okay, we've talked at length in this video about applying a percent increase or decrease. That's the thing with the 100 where you add something or take away something. However, we are looking now to find out what was the percent change. It's the exact opposite of applying a percent change that we already know. And the formula for percent change is nice and simple. It's the change over the original amount. Change over original. And so if the height is, let's say we have this week and last week, it's saying that this week is 1.25 times last week. So if we call last week x, we can call this week 1.25x. So I kind of put this in reverse chronological order, but the chronology is going from here to here. Now that x, it's kind of like saying 1x, because any number has a 1 in front of it, or any variable also has a 1 in front of it. So now, what's it changing as it goes from 1 to 1.25? It's changing by 0.25x. And what was it originally last week? It was 1x. So the x's can cancel. 0.25 over 1. And any number is itself over 1, so this is the same as 0.25. Now, what's 0.25 as a percent? You're moving the decimal over 2 spaces, so that's 25%. And that's D for number 26. And now we're going over to number 27. 27 is a very, very important question because it could cause a lot of confusion if you're not ready for it. We saw a lot of these on the early SATs that came out back in 2015, 2016. It's the idea of plugging in parameters. Once you're familiar with it, there's nothing too challenging about it. But basically, they're telling us that the growth is going to be between 36 and 48 inches per year. So plugging in parameters is the idea of saying, okay, what if it's 36 inches per year? And what if it's 48 inches per year? And we're going to figure them both out so we can get the answer to the question with no guesswork. So this is a 30-year period right here. And so if we're starting at 240, it says when it's 15 years old in the beginning, then it's going to be 240 plus 36 for each of the 30 years.
But if it's growing by 48 inches per year, it's going to start at 240 and it's going to grow by 48 every year for 30 years. So these are kind of some almost like linear with, b plus mx for each of these. In any case, this, if you throw it in your calculator, comes out to 1,320. And this in your calculator is 1,680. And that's why our answer for 27 is actually D. Now we're going over to 28. 28 takes advantage of that sort of Latin understanding of the word percent. Per is 4, and cent is 100, so 4 100. So if I say P percent, another way to understand that is P for every 100. So now we're just kind of writing an algebraic expression. Of in math means multiply, and is in math is an equal sign. So P percent of X, so let's not write the X for the multiplication symbol because that's confusing. So P percent times X is 3. And now let's just start simplifying that. X is really X over 1, any number is itself over 1. So right now we have Px over 100 is 3, and we're being asked to get X by itself. So to get rid of the P and the 100 all at once, we can multiply by 100 on the top and P on the bottom. So we can do that to both sides. You don't do it to both sides, it's not allowed. And the 100 cancels with 100. P will cancel with P. That gives us X on this side. And now to multiply these two guys, we have to remember that 3 is really 3 over 1. So that's giving us 3 times 100 all over 1 times P, which is C for number 28. Now we're going to number 29. So 29 is asking us for the equivalent form of the function that is going to give us the y coordinate of the y-intercept. So that's a mouthful there, but they're dropping a key word for us, y-intercept. And we should know that for the y-intercept, that means x is 0. For the x-intercept, that means y is 0. So let's just throw in the idea that x is 0 because they said y-intercept. So that gives us f of 0, which is 3 to the negative 2 times 0 plus 1 power. And we'll simplify that. 3 to the negative 2 times 1, 3 to the negative 2. And a negative exponent means something's on the wrong side of the fraction. So 3 to the negative 2 is the same as 1 over 3 to the 2. And that gives us 1/9. So which of these has the y-intercept showing up, displaying in the function? The 1/9, that's answer choice B. It's got a 1/9 right there, and therefore the answer to 29 is B. Now let's go over to number 30. 30 is asking us, what is most likely the reason why A has a larger margin of error? Well, in our data collection questions, which come up a lot, we say that there are 3 things to look for. You can't have any definitive statements. You can never say what's definitely going to happen in the future because no one really knows that. You can't have any bias, so it's not a good idea to go to a baseball game and ask people who likes baseball. And you can only reflect on the group that you sampled. But the way margin of error relates to that is the idea that for these data collections, you're taking a sample. I have a big population here, and it would be a lot of trouble to sample that whole population. So you take a little snippet of that population, and that's our sample. And if, let's say, within this sample, we know that 80% of the people all like TikTok, then it would make sense to assume that 80% of the whole population likes TikTok. Although we can't say definitely because we didn't count them all. But what is the amount of error? If that sample is a small snippet of the population, we're going to have more error because it's just not close enough to the whole population. But the bigger that sample gets, if we sample this much of the population, we're likely to have a more accurate sense of what's going on in the whole population. Similarly, if I went ahead and sampled everyone in the population, the entire population, my data is likely to be a lot more accurate. Why? Because I actually counted everyone. I actually know. I have the right to say, here's what I think about this population, because I actually went through all the trouble to ask every single person in the population. And so that's the idea. The larger your sample, the larger a percent of the whole population your sample is, the lower your margin of error. So why does A have a larger margin of error? Because they sampled less people, a smaller percentage of the population than B did. So sample B most likely included more visitors. In other words, sample B got a bigger sample of the whole population than A did. And that's the reason why the answer for 30 is B. Now we're going to question 31 here. '31 says, this limestone piece that we're talking about grew at a rate of 1/8 of a millimeter per year. How many years would it take for it to grow to 4 millimeters? So if we have 4 millimeters as our goal, and the growth is 1/8 of a millimeter every 1 year, so we can view this as a unit conversion. If we're getting 1/8 every 1 year, this is kind of like the number 1 because the two values kind of have the same magnitude in the way the problem is seeing them. For every 1 year, you get a growth of 1/8 of a millimeter. Doing it this way, the units cancel. Millimeters cancels with millimeters, and you basically have 4 divided by 1/8. Flip that, and you have 4 times 8 over 1, 4 times 8. And the answer to this question is therefore going to be 32. Now we're going to question 32. Classic SAT to make the answer to 31 32. Then when you go to 32, you're just confused. But here they're asking us for 2x. Now, as a general rule, when you're given a system, let's type that out here. When you're given a system of linear equations and are being asked for, not for x and y, but for an expression, for instance, 5x plus 5y, you want to start by simply adding or subtracting, that's more rare, but it has come up, the equations. So this is a perfect example of that. Here, we're not being asked what are x or y, we're being asked for 2x. So if we just take that yellow rule there as a rule of thumb, we can just add straight down and hope for the best. 2x this cancels, y minus y cancels, and 10 plus 4 is 14, divided by 2, and you would get x equals 7, but be careful there, because they want nothing more, or it seems like they would want nothing more than for you to go ahead and put 7 in here, because we're in the habit of finding x. But they weren't asking us for that. They were asking for 2x. So that's 14 for question 32. Going over to question 33. Once again, here we're not being asked for x, we're being asked for x minus 3. So we call this corralling. It's just the idea of moving things around until you get what you want. So let's try to get this x minus 3 all by itself. Let's take away 10 from both sides. So we have 3 root x minus 3 equals 12. Now that radical is being multiplied by 3, so we can divide by 3. And we have radical x minus 3 equals 4. And now if we square both sides, so put a little 2 right here and a 2 right here, we can see that x minus 3 equals 16. And 16 is our answer for question 33. Now we're going over to 34. For how many laps was the average speed greater than or equal to 150? So 150 is right here. So these numbers are greater than or equal to 150, and everything bigger than that is greater than or equal to 150. So how many laps was that? It's these 57, these 52, and these 35. And we'll just add those in our calculator. 57 plus 32 plus 52 plus 35 is 144. And that's our nice, easy answer to number 34. Now we're going to 35. That question is telling us that the mean distance for Bella's attempts was 0.3 greater than the mean for Aditi's attempts. So let's just show that as an equation. The mean for Bella, well, the average is just adding up all the numbers and dividing by the number of numbers. So if I add up all these on my calculator without the x for now, 4.4 plus 3.7 plus 3.8 plus 4.6, that's 16.5. So Bella's average is 16.5 plus x, that's the sum, divided by 5, because there are 5 numbers there. So this is Bella's average. Aditi's average is a lot easier because there's no x. We're just going to add those numbers and divide by 5. So 4.2 plus 3.8 plus 3.2 plus 4.0 plus 4.3 is 19.5. So it's 19.5 divided by 5. And that gives us 3.9. So now the question was telling us that Bella's average is 0.3 greater than Aditi's average. And for Bella's, we can put 16.5 plus x all over 5. And for Aditi's average, we can put in the 3.9 that we found. And now we can just start solving that. So 3.9 plus 0.3 is 4.2. Now we can multiply both sides by 5, and we'll get 16.5 plus x equals whatever you have for 4.2 times 5, which is 21. And now we can take away 16.5 from both sides, and we get our answer, which is 4.5 for number 35. Now we're going over to number 36. 36 also drops one of our favorite code words in the whole SAT, which is the word x-intercept. Like we said earlier, the x-intercept means that y is 0, the y-intercept means that x is 0. So this is y equals 0. Throw that in there. Look how easy this is. 5/4 x plus 2/3 times 0 equals 1. 5/4 x. Now this all becomes 0. Anything times 0 is 0 equals 1. Now to get that x by itself, multiply by the opposite fraction, 4/5, and we have x equals 4/5, and that is the x-coordinate of the x-intercept, 4/5, for number 36. Going over to 37 now. What is the perimeter of an equilateral triangle with a height of 5√3? Now, dealing with equilateral triangles is a very important higher level thing you want to be able to do on an SAT. Now, anything that is equilateral will also be equiangular. And if the angles of a triangle add up to 180 and all three of these angles are the same, divide that by 3 and you'll get 60, 60, and 60. So let's fill that in. We have 60 right here, 60 right here, and instead of putting 60 at the top angle, we're going to split this down the middle and make it 30 and 30. So the idea of splitting an equilateral triangle into two equal halves and making them 30, 60, 90 triangles, that's a staple thing you want to be able to do for the SAT. And you also want to be really sharp with 30, 60, 90 triangles. No one should have to tell you to put x, 2x, and x√3 where they go. Now that is on the formula sheet, but if you're looking on the formula sheet, then sorry to tell you, you don't know it well enough. You need to study a little more. So we have our x2x, x⁻³ for both of these special triangles. Now if the height is 5√3, then that x√3 is the same as 5√3. We just found out that x is 5. That means that 2x is 10. And if we want the perimeter, it's going to be 10 plus 10 plus 10. And the answer to the question is 30. Going over to our last question now. Here, we're looking for this system to have one solution. Now, if we have multiple equations and we're talking about a system, that's a fancy way of saying that we're talking about the intersection between these two functions. And I might even call this a high-level intersection. And one of our rules that we talk about a lot for the high-level intersection, a situation where you have two things that are not necessarily both lines, you want to know that you should get them both in the y equals format and set them equal. So let's go ahead and start that. That basically entails saying that -3 is equal to x² plus 10x plus a. Another rule that you want to be really sharp with on the SAT is when a question is talking about the number of solutions, not the actual solutions, but the number of solutions for a quadratic, that's code for the idea of the discriminant. Now, the discriminant is part of the quadratic formula. You should know the quadratic formula by heart. It's not provided for you on the SAT, but you do need to use it a bunch of times, so you got to memorize it. -b plus or minus the square root of b² minus 4ac all over 2a. Now, I'm going to make up fake numbers to show you what the discriminant is all about. Let's just say that the numbers work out such that we end up with 2 plus or minus √4 all over 3, 2 plus or minus √0 over 3, and 2 plus or minus √4 over 3. Now the discriminant is the thing under the radical, the b² minus 4ac. So if it were positive, 0, or negative, what's going to happen each time? Here, if the discriminant is positive, we're going to get two solutions, because if we were solving this, it would be 2 plus 2 over 3, 2 minus 2 over 3. The answers would be 4/3 or 0. So when the discriminant is positive, you have two solutions. Here, if the discriminant is 0, we're not really adding or taking away anything because there's just a 0 there. So the answer would be 2/3. There would be just one solution. And last but not least, if you have a negative, then we're not really allowed to proceed there because we have a negative under a radical. And there's only two real things that are not allowed in algebra, a negative under a radical or a 0 in a denominator. So this is the proverbial no solutions. If you did have an answer, it would be imaginary, which in most situations doesn't really apply. So the idea of the discriminant is for you to know that if the thing under the radical is positive, 0, or negative, that's going to impact how many solutions you have in each of these situations. So, proceeding with this question, we want to say to ourselves, of course, this is a quadratic. A quadratic is where you have your x squared, y equals x squared, or any variation of that. So knowing that this is a quadratic, you want to get it equal to 0. So I'm just going to add 3 to both sides, and it would look like this. X squared plus 10x plus a plus 3. And our a of our quadratic is 1, our b is 10, it has the x next to it instead of x squared, and our c is a plus 3, even though that's a little confusing. But if we want to have one solution, that's this situation. The discriminant has to equal 0 for there to be one solution. So the discriminant, the b squared minus 4ac, the part that is under the radical, needs to equal 0. So b squared minus 4ac for this question is 10 squared minus 4 times 1, which we don't write because multiplying by 1 doesn't do anything, times c, which is a plus 3, and that equals 0. So now we're just solving. 100 and distribute the negative 4 minus 4a minus 12 equals 0. 100 minus 12 is 88 minus 4a equals 0. Now we can add 4a to both sides. 88 equals 4a, and divide by 4, and you get a equals 22, and that's our answer for 38. Thanks so much for watching our video on the solutions for March 2022 Calculator Math section. If you're interested in finding out how we can pair you up with one of our grateful tutors to prepare for your next test, go ahead and find our contact info on the About page on our YouTube page and give us a ring, send us a text message. We'd love to help you out. And if you feel like these videos are really helping you to achieve your dreams, feel free to smash the thanks button and contribute to the production of these videos. Thanks so much, and have a great day.